In the 185 quite long and somewhat arduous years that I have been alive, there has never been a proper studio guest here in the Fat Cave. And I'm very pleased to say we'll be popping that cherry next. I'm John Cadogan from AutoExpert.com.au, and I get new cars cheap for buyers here in Straya, despite the frigging semiconductor shortage. Website for that, obviously, or you could just... Up there now, dude, click it. You know you want to. Graeme Gambold is a mechanical engineer, and somewhat like me, he graduated way back when they still used gas to illuminate the streets. Remember that? And slide rules to crunch the numbers. Those were the days. He's been a professional rally driver, competing in the Asia-Pacific, Australian and Vickwhegian Rally Championships. So he can certainly drive a car from A to B. There's a long suspension R&D pedigree here as well, including suspension testing and development for Nissan, and that was way back when my twin half-brother Phil was recording Separate Lives, One More Night and Sussudio. Remember that? 1985 was such a big year for him. Then, of course, G Squared went on and did essentially the same thing, not the songs, the suspension tuning, for Toyota Australia, and then he moved up the ladder for TMC, where he became the senior test driver for the Lexus Advanced Vehicle Dynamics Group. This is a big deal, right? Like every year in winter, like our winter, TMC would fly a 747 freighter full of prototypes into Sheepshagistan in the South Island for counter-seasonal R&D in what's now known as the Southern Hemisphere Proving Ground, previously referred to colloquially as Snow Farm. No pressure on that job, right? Just get cars like the V8 and V10 Lexus LFA test mules just right. Like, just do it, dude. Most people don't even know there was a V8 out there in the wings. Anyway, today, Graeme is the chief engineer for the SHPG, the Southern Hemisphere Proving Ground, which basically hosts every vehicle manufacturer on Earth, plus the Tier 1 suppliers, plus tyre manufacturers for winter testing, and that would be during the Northern Hemisphere's summer. So that's nice and convenient. This facility actually makes year-round winter testing possible globally, right? The SHPG has 16 different test facilities and 500 engineers on site at any given winter's day. It's a big deal in R&D. I've been there once with Pirelli, and I can tell you firsthand that it is an incredible place. Like, dude, if only there were a country sort of nearby, but really flat and really dry and really hot, where a smart entrepreneurial dude could set up a hot weather test facility for usage in this way during the Northern Hemisphere's winter. Wouldn't that be nice? The DPPG, Dingo Piss Proving Ground. That would make Australia less shit. A man can dream. Anyway. When he's not chief engineering the SHPG, Graeme Gambold takes virgin Kia vehicles from South Korea and he tunes the crap out of the suspensions for our uniquely shit Australian roads. And he's been doing that for more than a decade. If you remember what Peter Schreyer did for Kia several years ago, like he's the bold Bavarian dude, the former Audi designer responsible for the TT, whom Kia poached in 2006 to write that ship stylistically for them. Most people in the game would know of Peter Schreyer, okay? He's a bit of a design legend. And I look at it like this. Graeme Gambold is the dude who makes those Kia vehicles drive in line with the way they look now, in Straya at least. And that's no small achievement in my book. If you own a Kia Stinger or a Cerato GT or a car of that ilk and you've tipped it in hard once or twice and enjoyed doing so, you've got G Squared directly to thank for that. He has forgotten more than you and I will ever know about vehicle dynamics, and it is a dead set pleasure to have him here in the Fat Cave today. I can't think of a better first in-cave studio guest. So, Graeme, welcome to the Fat Cave. You are my first in-studio guest here.
It's a pretty awesome experience coming in here.
Well, that's what you say now.
And the automatic tree removal coming into the cave, I really like that.
Yeah.
The dirt track leading in.
Exactly.
Fantastic.
Deep beneath stately Chateau Shitsville, as I say. Okay, so you are the suspension guru, in my mind at least, and you've done a lot of this stuff, and basically you've spent decades figuring out bump and rebound and all of that sort of stuff, a lot of it specifically for Australian conditions, right? So what is it about Australia that makes suspension specificity, suspension tuning specificity so important? Is it our crap roads or the buyers of the cars or both?
Bit of both, but primarily our crap roads.
So
And,
exactly how are they crap compared with, say, South Korea, Japan, Europe, America, China, the big markets?
It's, I mean, that's a very technical question. You can go on for hours talking about why and how, but fundamentally we use spray seal surfaces, a lot of spray seal surfaces, which is just basically a dirt road covered with a bitumen painted, coated surface, if you like. And that gives us what we call a high RMS, which is the road roughness measurement. And then they break up with our heavy trucks. So we've got a big American truck network here. You know,
Everything arrives by trucks, right?
Everything arrives by trucks.
And distribution facilities out in the west of Sydney, and etc.
I mean, one of the roads we use here in Sydney or north of Sydney here is a major quarry route for building Sydney, I guess.
Yeah.
So those trucks give the roads up there a real hammering, and the local authorities resurface the roads probably every 12 months. But that's something that you don't see in a lot of parts of the world in sophisticated markets. So Australia's a sophisticated market. They want to drive good, confident, well-balanced cars that are got a good quality feel and a good accuracy on the road. And to do that on rough roads is a challenge.
Is there an excuse for the crapness of our roads, such as, for example, where the population of 26 million people, but a land mass that's kind of the size of North America? Is that part of it?
Well, the fact is we don't have a lot of roads here in Australia, so for people to travel around, it's the density of the road network is all eastbourne, all east coast.
Seaboard stuff.
So those roads get a hammering. So pretty high traffic volume on the roads that we've got, and they're large geographic mass, or distances. So got to build them cheaply, and they get damaged.
Okay, so talk to me about people buying cars and their expectations as well, because I get the feeling like there are some segments of the market that are really attuned to suspension performance, like if you're buying a Stinger. Okay, and I'll use Kia as an example because you do a lot of consulting work for Kia, setting those cars up. If you buy a Kia Stinger, you care about its dynamic performance because it's that kind of car. If you buy a Carnival, hasn't it just got to be good enough?
Probably for the punter who buys it, that's the expectation, or that's the thinking. They probably don't think a lot about vehicle dynamic performance in their marketing and purchasing decisions. But from our point of view, we've got to make sure that the car's fundamentally safe, stable and dynamic, and a good driving experience, and not be so reliant on driving aids like lane keep assist and EAB and all those things, AEB. So we put a lot of effort into tuning the fundamental dynamics to make sure the car's safe and isn't going to have a crash. It's almost like a passive safety and a passive comfort.
Well, there's a lot behind you as the driver, and like you haven't had a million hours of driver training and all of that stuff. If you're just an average driver and you get in a car, you think, I want to go around this bend. And you just want the car to do it. You don't want it to complain, right? And you don't want it to have any nasty feedback effects. So how hard is it actually to get a car to that point where you think, going around this right-hand bend, and it just does that instinctively?
Well, that's all vehicle dynamics, and the car's got to be able to have a self-driving capacity, basically. I mean, one of the things that annoys me a little bit about Australia is our lack of driver education. And even though the motor industry is doing a huge amount to improve vehicle safety, we're not doing much to improve driving capability.
Well, it's a three-part equation, isn't it? It's the drivers, the road users,
Yep.
inclusive of pedestrians and their behaviour. You know, if you're crossing the road like this,
Yeah,
then you
exactly.
are opening the door a bit, and you're a road user as well. But there's the road users, and then there's the vehicles, and then there's the roads themselves, and they all have to work together, right?
Yeah, well, we talk about three elements to having an accident. One is the equity of the road conditions.
Yep.
So road quality and the road layout and design. The other's the driving skill of the operator. And the third is the vehicle in its dynamic performance and its level of automation. Now, as motor engineers, we can't do much about driver training and we can't do much about road construction and maintenance, but we can do a lot about the vehicle. And we're doing a hell of a lot. Technology's doing a hell of a lot to advance cars in terms of electronic safety aids and all that sort of thing. But my job and my industry's job is to make sure that the car's fundamentally, you know, the moving mass, the 1,500 kilogram, 100 kilometre per hour moving mass that is a car on the road, that it's safe and capable of doing it. And we try and get it to the point where it's got a high level of self-driving. So things like the polar moment of inertia control, your response, your acceleration, all those things are things that we're looking at all the time when we're talking about the tuning of the car.
Okay, so we're both proper propeller. Oh, you're a proper propeller head, and I'm a pretend propeller head. Polar moment of inertia is how hard it is for something to do that in space, right?
Yeah.
Like how hard it is to start and stop rotating.
Yep.
It's like having a dozen eggs, take 8 eggs away and put 2 eggs here and 2 eggs here. That's a high polar moment of inertia situation, and the 2 eggs here and 2 eggs here, that's low polar moment,
Yeah.
right? So this response is kind of important, right?
Absolutely.
And it's a balancing act, okay? Because
Absolutely.
if you've got high speed stability, if the eggs are here, but it's hard to turn.
Well,
right?
and the thing like the different type of vehicle or a different size vehicle, you got your 8 eggs up this end and 1 up here.
Yeah, or if you've got it's not the eggs, it's a Carnival. You can have 800 kilos of people in it and 2 tons behind,
Yep.
and you've got to have control at the same time as if you've only got some schmo in the front and the vehicle's completely empty.
Yeah, that's right.
So there's a huge dynamic sort of mass variations
Yep.
in vehicles
And
like
electronics, like electronic stability control and your inertia control and all that sort of thing, they're great, but they're all reactive systems. So
Something's
there's
gotta go wrong
be
first,
an
right?
acceleration
Yeah.
around the polar moment before those actions will be, will intervene.
that. Okay, so when
So
you
we're
get
trying to set up the passive dynamics, which is control the acceleration and not let it get to a trigger point.
yeah, and when you say acceleration, you don't mean acceleration
No,
like
not
most
straight line,
people think
yeah.
on a drag strip. You mean rotation
Yeah,
and
your
all of that
acceleration
stuff.
mainly,
Yeah,
yeah.
rotational
Yeah.
stuff. Okay, so car comes out of the factory, or prototype comes out of a factory, and it comes here, and a lot of those things are already locked in, like all the suspension geometry, the points where the arms bolt into the body,
Yep.
and all of that stuff locked in. So you can't tweak that. You've got things like dampers and springs and bushes that you can tweak, maybe tyres as well in some cases, I don't know. But what do you do?
So we start by getting the design information, all that stuff you talk about, or what we call the hardpoint engineering,
Yep.
or kinematics,
Yep.
which is the skeleton of the car, if you like. We get all that design information down from, in Kia's case, from Korea, and then we put that into a simulator or a calculator, and we look at things like yaw rates, mass frequencies.
Okay, so your is this rotation, left to
rotation,
right.
yeah. And that's influenced by mass front and rear. So we look at roll centre heights, roll moments, centre of gravity, and then we can do a calculation on all the.
Okay, so the centre of mass, because not everyone's a propeller head.
Yep.
Centre of gravity, centre of mass. That's where you can assume all the mass is concentrated
Yep.
in a thing.
Yep.
And the roll centre is
The
where
roll
it
centres
rotates a bit.
are the levers, if you like, down
Yep.
in the suspension, both
Yep.
front and rear. So the front axle assembly's got a roll centre,
Yep.
a roll centre height, and it's got a centre of gravity height, even
Yep.
though it's the centre of gravity, or the whole mass is in the centre of the car. At the front and rear axle, just a proportion of that weight is above the roll axis.
Okay, so
But
you've
we call
got
that the roll
okay,
axis.
So you've got this, right?
Yep.
You've got the roll centre here.
Yeah, which
and
is
the-
where all your suspension points come in and pivot.
Yeah, and the
pivot
car's this way,
Yep,
right?
yep.
So let's assume this is the front.
Yep.
Okay, the roll centre's down here,
Yep.
all right?
And then
and
your
the
mass
mass
is
centre's
up
up
here.
here. So
That's
when you
right.
go around a corner,
That's right.
that happens.
Yep.
That's what you're talking about.
Yep. So we look to control that rate of change with damping.
Yep.
And on the outside of the corner, we'll give compression damping, and on the inside, we'll give rebound damping, and the stabiliser spring to connect the two axles, two sides of the car together.
Yep.
And we'll control that rate of movement.
You mean anti-roll bar?
Anti-roll bar,
spring.
yep,
Yeah.
yep. So we control that rate of movement with dampers.
Uh-huh.
But the dampers don't control the actual total amount of movement. So then we do frequency calculations, and we do vertical ride comfort, or what we call vertical frequency, which is the mass over the width of the car, the
Yep.
track width of the car.
When it does this.
Yeah, when
Just
it's
for
doing
vertical
that.
movement. Yeah.
Yep, and then we do what we call single wheel or roll frequency calculation. And we look to maximise that roll frequency in the car across, so make the car stiff laterally,
Mm-hmm.
and then keep the vertical frequency at quite low.
Because this is one of the things that always amazes me about cars, all right? Because you've got roll performance that you just talked about, and you've got vertical performance like bump and droop performance.
Yep.
And you've got, essentially, with the exception of anti-roll bars, you've got the same components controlling both of those aspects of kinematic movement, which is pretty complex because you could get one right at the expense of the other.
Well, they always are working together. So yeah, if you rob Peter, you've got to pay Paul. You know, it's if you make the thing vertically stiff, it's difficult. You're going to lose lateral stiffness too. So there's certain things you can do to address that balance.
Yep.
And head in a certain direction, but you can't have total modal separation, which they do in Formula One and the like. Formula One's got, it has total separation of all its motion frequencies.
Yeah, sure.
We can't do that in road cars. They don't have.
Because you've only got that limited capacity of those.
We've got 4 dampers, not 6.
Yeah,
and all
you've
that.
got crossover
Yep.
components doing
that's
two
right.
jobs,
Yep.
right?
Yep.
And they're probably better at one job than the other.
Yeah.
They certainly are in EVs, right? Because if you drive an EV, like I spent nearly a year driving a Kona electric, okay, and it's really stiff in roll
Yep.
and okay in bump
Yeah.
because of all that mass down
Yeah,
here.
you got a
It's
lot of
changed
mass.
the performance. Yeah.
And EVs are a completely different kettle of fish.
We'll get to that in a minute.
Yep.
Now, what is the process, though? And you do these calculations. Let's go back to when you stop doing calculations and you actually start going out and playing with the hardware. What do you do? Because you probably don't play with it. There's probably a process.
Yeah, so typically we set up a model.
Mhm.
So we've done all our kinematic reviews. We've got all our components. We know what spring rates we want to start with. We know what stabiliser bar rates we want to start with. We even have very accurate now damper prediction
Mhm.
models. So during COVID, it's a bit of a different process. Normally we would
bet.
go to Korea or go overseas and work with the suspension engineers to do some fast tuning at one of the proving grounds and get to a starting point for a localization program.
All right, so this is like your baseline for Straya,
Yeah.
where you think we need to be.
Yeah.
Yeah.
But of course, going to a foreign proving ground, there's no Australian roads there.
Yeah, right.
So we've got to make some calculated guesses, if you like.
Mhm.
But typically we would then come back and start a tuning process. But under COVID, we can't do that. So we're going straight from paper and prediction to getting hard parts made.
Right.
So we're getting special shock absorbers sent out, prototype shock absorbers sent out, and then we put them in the car and we physically go for a drive, and that's the subjective evaluation side of the business.
Okay, so that sounds to me like a tremendously iterative process. Like where could you stop? You could put thousands of different combinations of valving for
Yeah.
shock absorbers with dozens of different combinations of spring rates, and where does it end? I mean, so how do you do this in a directed way so that you arrive with the fewest number of permutations at the Goldilocks setting?
It all starts back with the kinematic paperwork. We've got to get those models as accurate as we can.
Yep.
And with an accurate model, you'll end up not having too many steps in the process of subjective evaluation. Typically, we'll tune and try probably 10 shock absorber combinations in our process.
Yep.
And pretty quickly you arrive at the ones that we want. Like I say, during COVID it's a bit difficult because we're actually getting stuff sent out from Korea, whereas normally we'd have an engineer here working with us and making our own dampers. and tuning our own, what we call MDPS software maps for the steering. But at the moment we're doing all that by correspondence, so it slows the process down a bit. But the net result, and the end result, is about the same. It's just much slower during our COVID program.
So what is the difference then between a car like a Stinger, which is a grand touring car by any estimation, it's a good grand touring car, and Kia Carnival? Because you're looking for the Goldilocks tuning response, like there's a target, but they're different targets. So how do you define the difference in the target?
Comes back to damping ratios. So the primary data that we put into our kinematic model, one of the primary data inputs is the desired damping ratio, which is the fundamental stiffness of the shock absorbers and the motion frequencies of the car. So on something like Stinger, we'd run, a front vertical spring rate of 1.3 hertz, whereas on something like a Carnival, we'd be down at 1.2 hertz. So,
which is about 8% different or something.
Something like that, yeah. So fundamentally, mechanically, the car's softer in its kinematic motions.
Because you think they're chalk and cheese, but you're only talking about numerically an 8% difference.
Yeah, they're not that different.
Here's a weird thing, right? I've always oddly enjoyed driving a Carnival, and I want to hate it because it's a people mover, and I always enjoy it, and it always feels kind of instinctive to drive it. It's oddly nice to drive a Carnival, and I don't want it to be that nice. So I blame you for this sort of paradox in my head.
Well, thank you, but it's all the result of the figures. We put the figures in, and we want all the cars to be similar. I mean, we don't have a much looser tolerance for double lane change stability or something from a Stinger to a Carnival. That's all defined, but the actual performance difference is a little bit the tuning in terms of those frequency variations, sports versus luxury.
Because this is one of the things I think ordinary people don't appreciate, is that, and particularly people who think, oh, I'm going to modify my car, I'm going to put these stiffer springs in, or it'll be better. You can engineer in these horrible sort of tipping points where you don't even realise there's one out there waiting until you're on a bit of a greasy road and you have to swerve around a kangaroo or something, right? So what you're trying to do, in addition to make it feel nice to drive the kids to the shops or something, or school, is make the car stable in extremis when you might otherwise wrap it around a pole or a tree.
Yeah, exactly, yeah.
This is pretty serious stuff, right?
It is, yeah, absolutely. And it's a big part of our tuning process. Like if a car's got a lot of ESP activation in normal driving, one, it can be the driver inputs, but two, it can be the passive suspension tune, not controlling the motion of the the weight motions and not behaving naturally with high levels of stability. So
so what you're saying is the more you get your end of the deal right, the less there is the chance for activation of those systems that are really just there to save your neck when something goes wrong.
Yeah, because all those systems, all those electronic systems are triggered by logarithmic targets, so tables. So if the ESP system sees a lateral acceleration climbing at so many degrees per second, then or so many meters per second, it'll trigger the ESP to come on.
Yeah, because it's not it's not like you, like it can't see the corner that you're driving at.
No,
but
it's doing a prediction.
It can see the steering angle and the yaw rate of the car, and it can look at what's happened in the past and go, oh no, this is about to go Chernobyl on us here.
Yeah.
Better intervene now.
Yeah, because it's got a predefined map that it's got to activate on. If the acceleration spike goes outside, it'll activate. So our job is to make sure that those accelerations and those body motions are all in check.
So
mechanically?
So what's easier to get right? Is it easier to get a Stinger right, or is it easier to get a Carnival right?
Oh, that's a difficult question.
Because there's so much more variability with Carnival, right? There's the towing capacity, the 800 kilos of people, the 200 kilos of luggage in the back, or dead empty. That's got to be a fundamental difference.
It is, but then something like a Stinger gets great scrutiny from you guys. So, we've got to make sure that Stingers,
How do you feel about that scrutiny? I've got to ask you: how much of it do you think is unwarranted or even a poor conclusion based on the product? Without naming people specifically, just do you think a lot of the criticism is on the money, or do you think a lot of the criticism could be off the target?
Oh, look, I always read press and media critique and try and read between the lines, because for two reasons. One is that all you media guys are very current with all of the market's offerings. So if you make a strong criticism of one of our cars, it sort of almost infers that we've missed something or we're not on the right page. So, you know, we do take that in and we do review it. So if there's strong comment about a particular phenomenon or a particular car's performance, you know, we want to hear it, and we hear it from you guys. Do we tune for media cars, or we tune for the end user? We always tune for the end user.
I think the job of reviewers is really to review the car in the context of the person who's going to drive it. Because if you really...
Very much, yeah, that's very important.
If you're scrutinising the throttle off oversteer characteristics of a Carnival, you're probably doing your job as a reviewer poorly, you know?
Yeah, but by the same token, a Carnival should be stable in that condition, because...
yeah, but you shouldn't be driving it like that. I
no,
mean,
but
that would be something that's gone wrong.
But in a potential accident scenario, just before you're going under the Kenworth truck...
Sure.
During your jackknife towing accident...
Yeah, absolutely.
All those... accelerations, all those dynamic forces are there.
And it's also not acceptable just to swerve and avoid a kangaroo. You've got to recover and get back in your lane before something comes the other way, right? Or a tree.
It's one of the reasons I'm a very big fan of market review programs like NCAP and these things, to actually start doing ISO double lane change evaluations, you know, moose tests, if you like. It's
dynamic stability tests.
Stability. So, and give us a rating not on how the vehicle's electronics perform post-incident, but give us a rating of how a vehicle's stability is and safety is to not let you get into the accident in the first place.
Yeah.
So I'd love to see a double lane change, you know, NCAP assessment.
Okay, so I just want to take you back to going out on the road. You've done your kinematic modelling.
Yep.
You've got your ballpark. Here's where we think we are. You've got your test shocks and your spring rates, and your bush is fitted to the prototype, and you're out there on the road doing it. How much of the assessment of that stuff is as a result of instrumentation that you do on the cars, you know, accelerometers and things of that nature, and how much of it is the seat of your pants and 20, 30 years worth of experience doing that stuff?
From my personal point of view, it's very subjective.
Right.
Because I've done 30 years of data logging and looking at motion frequencies and measuring everything. So
yeah, and if you'd done 30 years of flipping burgers, you'd want to be whipping up a pretty mean burger by now, right?
Yeah, and you should be able to do it with your eyes closed. So,
yeah,
you know, when we drive our cars, I know if we hit a bump, I know what piston frequency I'm looking at. I know what sort of, whether I've got a spring problem or a damper problem. I know if I'm undersprung or oversprung or whatever the issue is. So
do you get corroborating data of that? Or not really?
I can.
Right.
But the problem for us is it's very easy to measure stuff in the car, especially these days, you know, and in our, in one of my other businesses, we do a lot of winter testing, and that's all done through data logging. You know, measuring snow performance and tyre performance on snow. But we don't have the time for this sort of tuning, and we don't need to. So we can go out. I mean, by the time we get to tuning, we're almost driving the car like an end user. So we're saying, what's the end user experience? We know that we're...
So you go find some crap roads,
yeah, we go find some crap roads, not hard. You know? And we know we know mechanically from our paperwork that we're in the window. Right. So we know that we haven't got a fundamental imbalance front to rear in vertical or lateral motion frequency or something like that. We know that our damping rates are in our predicted window. So we know that mechanically we're all correct. It's all been ticked off.
And how long does this process take? You know, Kia rings up one day, and you're locked into Kia. You do their local development for suspension tuning. They ring up one day and they go, "We've got a new product." How long until you're talking to the press about it just before it goes on sale?
Depends on the model. If it's a completely new model, it's a bit longer. If it's a facelift, we're sort of well down the track by the time we start tuning a facelift. Yep. With a new model, it's typically 6 to 8 months. And it's not so much a phone call. We have a very carefully developed product planning pathway and project, so we know what's coming almost 3 years in advance.
Yeah, right.
So, but the process for us in terms of tuning for the local environment starts about 6 months out. And as I say, normally it would be a week or two at the research centre in Korea, working directly with the shock absorber engineers there. It was very fast. We've got all the dynamometers, all the shock absorber dynamometers, all the spring range, all the mechanical components, and we can do 10 iterations a day if we need to.
Like Lego for shock absorbers.
A bit like Lego for shock absorbers, and very quickly get a feel for the vehicle's responsiveness to over and under damping and all those things. And having a proving ground there's a whole plethora of different surfaces and different road conditions we can quickly run across.
Yep.
So we nut through all that stuff, get the car into a zone, and then we come back and we do 2 weeks of subjective evaluation tuning here in Sydney or Melbourne or wherever we'd like to go.
Yeah, right. And then the rest of it is obviously them implementing that into production.
Yeah, and then we get involved a little bit in the quality validation process to make sure that our prototype shock absorbers can be made and carried into production.
Yep.
And that the force variations in the pre-production versus the post-production samples are all correct.
Just sitting here talking to you about this stuff, right, it really does make me wonder about, and I try not to be too hard on them about this, but backyarders modifying cars, they don't have the resources to do this kind of thing. It's easy to make a car worse.
It's very easy to make a car worse. I do it every day.
Perfect.
But
and then you undo it.
And then we try and undo it.
Yeah. But if you're a punter, you go and buy one set of springs, right? Or you go and buy one set of dampers.
Yeah.
And then you're kind of at the mercy of the person who's tuned them.
Yeah.
And
I think
this allegation of making it better might be at the expense of some other aspect of the car's performance that really does matter.
Yeah, it's probably not so much that they're actually trying to make it better. They're probably trying to move it from a design intent into a more specific demographic of their user market.
Make it better on the track or something.
Make a Carnival into a Carnival GT or something like that.
Or make a Stinger even better.
Or make a Stinger even better. But then if we did that as OEMs and put that to market, would we be alienating the market and not selling as many cars? One of the other things we try and do is make the vehicle as available and suitable to as wide a market demographic as we can.
Well, I guess most people who buy a brand new Stinger, the majority mode of operation of that car is driving to the office.
Yeah, absolutely. So it doesn't need to be...
But it's got to be good at that.
Yeah.
Right?
It's got to be good at that, but it can't be a track special. So we're not trying to make it a track special.
It's got to be engaging, but is it
It's got to be engaging, but it's
okay, so from your point of view, is it harder to make a Stinger engaging or harder to make it good to drive to the office?
It's a good question. No less hard, but different paths to take it down. So if the directive from product planning was to make this a track special, you just go and make it a track special. Change your frequency numbers, give some high rates. And
but it would be awful to drive on.
But it wouldn't
in
be
traffic
great to drive in traffic, and
those
it wouldn't be great
freeway
to drive
bumps
on.
that are ba-boom, ba-boom, ba-boom,
Or Sydney step joint roads,
Uh-huh.
concrete roads, and all that sort of thing. So, we're always trying to find in Stinger, and we were talking earlier, which is easier, Stinger or Carnival. I'd say probably Stinger because it's a more discerning market, but it's also harder to get that balance between 95 percentile dynamic performance users and the day-to-day driver.
Yeah.
Whereas tuning a Carnival, it's even though we do a lot of tuning with it laden and semi-laden condition to simulate an end user's typical daily drive, it's an easier thing to achieve because the car hasn't got to have this 95 percentile track performance. So the frequency numbers are in a more fat part of the zone, if you like.
Yeah. Okay, so the final thing I want to talk to you about is the electrification of the automotive industry, right? And an aspect of that never gets a run, which is dynamic performance, okay? What we've seen so far is a whole bunch of EVs that are adapted from internal combustion platforms. And as I see it, that's the elimination of several hundred kilos of mass right up the pointy end, and then the addition of several hundred kilos of mass, probably a few more hundred kilos of mass, just underneath the floor. And that's got to be so fundamentally different, like out there, beyond what you've seen before.
It's not just under the floor, it's towards the back under the floor typically, because the where the fuel tank was is a great place to put batteries.
Yeah, so
lithium-ion
60-40 as opposed to 60-40.
Yeah, that's right. So that's exactly right. We're seeing sort of 60% of the weight at the back of the car, which turns your car into a forklift overnight. So, all those things that we were talking about before, vertical ride frequencies and
well, the mass centre's down there near the roll centre now.
And the roll centre's very low.
Yeah.
Well, the roll centre's not that low. It's about the same, but...
the mass centre's moved a lot closer to it.
The roll moments are much shorter.
Yeah. So intrinsically less body roll in corners.
Less body roll, but then less forgiving too.
But more bump, and particularly at the back.
Yeah, more bump
vertical
at the back.
movement in response to inertial inputs.
Bigger springs, much bigger springs, double the spring rates in electric cars at the rear.
Wow.
Which means double the damping. Short roll moments, so...
Got to make sure that someone overcooking it, lifting off, doesn't back off the road.
That transition between... We talk about car in terms of it driving down the road and going straight to going into a corner as two parts. There's the transient response and then the settled steady state response in the corner.
Sure.
And we're looking to always reduce that transient time to a minimum, so shorten the transient response and get into the settled steady state faster, and for it to be nice and compliant and absorbing in those rough corners.
And I guess coming out of a corner is the same thing in reverse.
And coming out of the same...
Less transient, but you've got to start coming out and then you've got to adopt a straight line attitude.
Go back to straight.
Yeah.
And with short roll moments, that becomes a bit more of a knife edge.
Yeah, right.
Those transitions are sharper, don't have the time for the shock absorber to bleed through and all those sort of things. So
is it going to be easier to tune once we see EV6 and other platform-specific EVs?
So that's part of this. Everybody talks about having an electric car platform, special platform for electric cars. Everybody's moving to that now, where the electrification of the motor industry has gone through its first phase, which is taking the current production offering and electrifying it to going specific design around battery mass and roll moment locations. And
so
all that sort
the
of thing.
fundamental geometry.
Fundamental kinematics are changing.
Yeah.
So, EV6 is our first product off a specialised and dedicated electric platform. So a lot of those inherent design compromises in going from an ICE platform, if you like, and electrifying it will be reduced. Still the same challenges though, controlling a large mass at the rear of the car and all that sort of thing.
At least you won't be dealing with an inherent sort of poor set of circumstances, like the compression of the reduction in the mass centre height relating to the roll centre. Presumably that'll be sorted out.
Yeah, that'll be sorted out. Yeah, exactly.
All right, well, I've detained you for long enough, Graeme, and you've just walked up to the knife edge of spilling your guts and saying things that you shouldn't say. And I think that's been very interesting because a lot of people don't appreciate the complexity. Like, everything's simple until you do it, right? Heart transplant, simple until you do it. And there's a lot of complexity in this, and I guess the proof of the pudding is out there in the driving, and hopefully it'll give the people viewing a chance to think about the work that's gone into the product when they actually get into the cars and drive them, and they do it seemingly without too much argument, Yeah,
well, if we've done our job well, people won't know. Like if we've got a great, confident car, people will just drive it and enjoy it.
Yeah.
So, our objective is to work really hard for something that most people probably won't experience. But it'll be on their side the moment they're trying to swerve around a kangaroo or get around that truck that's in front of them or whatever.
Well, for what it's worth, thank you very much for the unsung work that you do, because I think it is making a tremendous difference to the product, and I'm in awe of every conversation I've had with you, because I'm trying to keep up, and it's all this binary stuff about frequencies and all of that. I'm glad that you're coming to grips with that and not me.
You're an engineer, so you get it. But
there's a difference between getting it and doing it, mate.
Yeah, I'm not great at talking about all that stuff because it's what I do every day. But it's difficult to put it across to the public. But you're the skill there, so we need people like you in the motoring media to take what we do and explain it to people.
No, well, I love your work. Thank you very much for your time.
No problem. Thanks, John.
The Harry Potter of suspension tuning there, Graeme Gambold. Please excuse the production values too if you did find them a little rough around the edges. And hey, I don't know, haven't seen the footage yet. I can tell you this was not my first rodeo interviewing someone, but it's actually not that easy one-man banding the whole thing. Like in TV, you'd have a dozen people doing this. Running 3 cameras and the audio and the lighting, trying to make sure nothing's going to fall over mid-chat, and still figuring out what to ask next. Plus, of course, trying to keep up with a dude who can run rings around you on the subject at hand. There's that. Look at this interview like a test mule, a prototype of sorts, which we might be able to finesse into production if there's actually a latent demand in the market for that. To wit, I am wondering if you liked the format or if you thought it had potential, so please do let me know in the comments below. It seems to me there's just a shitload of talent out there in the automotive industry, locally and abroad, and this talent pool kind of exists in a perverse cone of silence, a vacuum of sorts. Nobody wants to talk to a journalist, right? I get the feeling like this talent pool deserves to be much better oxygenated. And pretty clearly, at least I hope, I want you to know that this was not that cheap kind of media blood sport interview. That was not the intent going in. And I hate that, where the objective is simply to trip up some poor bastard for the purposes of entertainment, because the media thrives on that. The news media does anyway. I tried to channel my inner Sam Harris or Joe Rogan with this interview, however imperfectly. And I'm certainly not comparing myself to those giants of podcasting, but I kind of tried to use their philosophical intent, okay? Look, I did it this way, the better to suck worthwhile information out of G Squared's brain and inject it directly into yours. That was the objective here. So, hopefully this is what an interview looks like, minus the malicious intent which is so popular in the blood sport mainstream news media. Anyway, if you like this kind of thing, do let me know. I'll try to find some other victims who are brave enough or crazy brave enough to run the gauntlet here in the Fat Cave with a terrifying geriatric Phil Collins lookalike such as me.